Welcome in the last section of our course. In this section, we'll be leveraging Monte Carlo tree searches and temporal differences in reinforcement learning. So let's see what we will learn in this section. First, we will be understanding asynchronous advantage actor-critic technique. The shortcut is A3C in the simulation. Then we will be setting up A3C environment. So similarly to the previous examples, we'll be using a little bit different API for our environment with states. Third video will be about configuring reinforcement learning program that is using A3C configuration. So up to this point, we're using Q-learning configuration. Here we will do a different approach. Fourth video will be about using A3C technique with actor-critic factory separate standard dance. So this is a class from the RL4J API. And finally, we'll start our program and we'll gather results. So let's start from the first video, in which we will be understanding asynchronous advantage actor-critic technique. So we'll see what is actor-critic technique, we'll be understanding actor part, and also we'll be understanding the critic part of our model. So what is an actor-critic technique? This technique will add yet another concept to our understanding of reinforcement learning. So if you remember from the previous sections, and particularly from the section number 1, when we were explaining the reinforcement learning algorithms, we have state, we have the agent, that was our actor, and also we have a reward. There was no critic part. Critic part is another thing that measures how good action made by model is. So it will take a value into account. Also, we will have an actor. It will control how our agent, decision maker, behaves. So this will be a policy. Let's take a look at roles of both of them. So actor is made an action, for example, moved player from point A to point B. So this is responsibility from the actor. It will be influencing the agent. So if you remember from the cliff-walk simulation, agent was our player to go from the point A to point B. So it will be an actor that will be moving that agent. Critic will rate that action. So when we did an action, we'll get a feedback in a way of reward and we will rate it. Critic will rate that, and if that is a really bad action, it means that we need to change it. So let's take a look at the graph and try to understand what the actor critics method are. So the critic estimates the value function. This could be the action value or state value. So we can get a state like environment or action. Actor updates the policy distribution in the direction suggested by the critic. So critic is responsible for telling our actor if that was an error or not. So based on a reward, critic is doing a decision, so it's choosing the subsequent actions. So in this actor-critic technique, we have two separate processes. Critic is responsible for interpreting rewards and actor is responsible for doing actions. In the previous approach, we get only one entity that was responsible for both of them. So based on those rewards, critic will do a decision, pass it to actor, actor will do an action, and then there is an observation. So agent has two processes. That is the most important thing that you need to understand from this video.